Hello class, today we're going to be going over lesson 3.1, how to analyze percents of numbers. So since this is the first chapter in our new book here, this is the first lesson in our new chapter, let's make sure we're all taking detailed notes so we can get off to a good start here. First thing we want to talk about is what is a percent. So our first definition for chapter 3 is a percent. A percent is a ratio in which the first term is compared to 100. Now, I know that sounds a little weird here, but let's think about what we've seen about percents in the past. Percents are something that looks like this, right? Like 62%, it's just a number with the percent sign after it. But 62% is the same in a number form. 62% is the same as 0.62. They have the same value. So how do we go from 62% to 0.62? Well, we simply focus on the decimal point that's at the far right of our number, and we move it over 2 spots. So for here, the 62 would be moved over from the right to the right of the 2, all the way 2 spots to the left of the 6. Now, what do I mean by 2 spots? We have 2 little jumps here, right? 1, 2. So we're moving it over to the right. Now, just like a percent can be written as a decimal, it could also be written as a fraction. And this is the same as 62 over 100. Because our decimal is in the 100th spot of a decimal. Remember, this is the 10th spot, this is the hundredths, and this is the thousands, 10,000s, and so on and so forth. So writing as a fraction, this would be 62 over 100. And of course, we could see that we could simplify this if we want, but right now we're not going to. All right, so our key concept for this unit is first off that we should be understanding that equivalent rates can be used to find percents. We're going to have some problems like that in the future. And we also that we can analyze our percents of numbers in a real world complex, or we can apply what we're learning in this video to solve other problems that will come up in real life situations. All right, so let's start with a warm up here. We want to write each number in 2 equivalent forms. So I think everybody could do this here, so I'd like you guys all to pause the video and try this on your own, and then unpause it when you're ready to hear my solutions. So let's start off with the 0.29. Well, since it's asking us to write it in 2 equivalent forms, that means we want to write it as a fraction and also as a percent. So going to a percent is pretty easy here. We just need to move our decimal place 2 units to the right. So 1 and 2. So as a percent, 0.29 would be 29% because we moved our decimal place over to the right. Now, if we want to write 0.29 as a fraction, well, we have to look at our decimal place here. What decimal place are we in? Well, we are in the hundredths place, so that means that our fraction should be over 100. So we would get 29 over 100. All right, next we have 35%. So to go from 35% to a decimal, we of course need to move our decimal place over 2 units to the left. Now, I know we don't see a decimal spot here, but remember, there's an imaginary decimal spot at the end of every single number here. So there's really a decimal right after this 5. So moving it 2 over to the right, 2 over to the left here, then we would be left with a 0.35. Now, I'm going to leave this in a decimal form to go to a fraction here because it's a little bit easier. We have to ask ourselves, what unit are we in? Well, we are in our hundredths place. So then we should do this as 35 over 100. All right, and lastly, we have a fraction. So going from fraction to decimal is definitely the hardest one here. We do it by long division, right? So our numerator goes on the inside, and our denominator goes on the outside. So how many times does 5 go into 2? Well, it doesn't. So we need to add ourselves a little decimal with a 0 after it. We'll put a 0 up top, and we'll bring our decimal place up. We need these to be in a straight line here. Now we can ask ourselves, how many times does 5 go into 20? Well, that's an easy one, hopefully. 5 goes into 24 times, and that would be indeed true because 2/5, not 2 2s. 2/5 to a decimal would be 0.4. Remember, we did this using long division, and that is the same as writing 0.40. I'm going to throw on another imaginary imaginary 0 after that because every number has a 0 when it's working like that in a decimal form. Now we need to move our decimal 2 places over to the right. So 1, 2, and 0.4 would become 40%. Now, what can we know about all these numbers here? Well, whether we're working with 0.29, 35%, or 2/5, all of the numbers that we converted to, whether it's 0.29 going to 29% or 29 over 100, 35% going to 0.35 or 35 over 100, or lastly, 2/5 going to 0.4, which is going to 40%. All of these are equal. They're all equal numbers. All right, now let's get into some new problems that we probably haven't seen before. We want to find the percent of each number. So for starters, we want to find 59% of 640. Well, the way we want to do this is we want to convert our percent to a decimal. So 59% will become 0.59. Remember, we were able to do that by moving our decimal place over 2 units to the left. We got 0.59, and now we need to multiply that by 640. So 0.59 times 640 will give us 377.6 would be our number for this one, and that is 59% of 640. Well, let's think about it. 50% of this would be 320, right? Because that's exactly half of 640. So it makes sense that 59% would just be slightly more than this. So this one does seem to be true. Let's go into our next one here, 20% of 3,542. So again, we need to go from 20% to 0.20, and then we need to multiply that by 3,542. All right, so 0.2 times 3,542 would be equal to 708.4. And again, this makes sense because this appears, or at least so much so appears, to be 1/4 of 3,542. All right, next we have 195% of 568. Well, 195%, this can be our first situation to see. Well, we're moving our decimal place over 2 units to the left. So we're going to have a 1.95. But notice, this is larger than 1, right? So our 568 will get bigger. And that makes sense because if you're having over 100% of something, then that original quantity should continue to grow. So 568 times 1.95, this should be just about doubled. This would be equal to 1,107.6. 1,107.6, so just under doubled it. All right, and our last one here, 74% of 920. So 74% will become 0.74, and we need to multiply that by 920, and that will give us 6,080.8. Oops, not 8,000, my apologies. So 680.8 would be our number for this one. All right, so what do we do on these? Well, the first thing we had to do is we had to convert from our percent to a decimal, and then we multiplied our decimal times our whole number there, and that gave us our percentage of a number. So like, for example, 59% of 640, we converted 59% to 0.59. We multiplied it by 640, and that gave us 59% of 540. Now I want you all to think for a second. Could we have used a different number besides the decimal form of this to multiply by our whole number there? And I'll let you guys all think about that, and we'll talk about it in class tomorrow. All right, so let's start with this one. A local Little League has a total of 60 players, 80% of whom are right-handed. How many right-handed players are there? All right, well, our 80%, we're going to have to first convert this to a decimal. So 80% is going to 0.80, which of course is 0.8. And then we need to multiply that by 60. All right, so I do know 80% is the same as 4/5. So 80% can also go to 4 out of 5. And we can multiply that by 60 as well. And I'm going to do that instead because it's a little bit easier for me than working with a decimal. So 4/5 times 60 over 1. Well, let's do some cross-canceling here. Our 5 and our 60 have a common term of 5. So 5 divided by 5 is 1, and 60 divided by 12 is 5. All right, now we can multiply these fractions together here. 4 times 12 is 48, and 1 times 1 is obviously 1. So this will just be 48. So if 80% of 60 players are right-handed, then that means there are 48 right-handed players. So I asked you last time that what could we do besides multiplying by a decimal to give ourselves a number? And the truth is we could also multiply by a fraction. So here we multiplied by 4/5 instead of 0.8 just because it was a little easier. But let's remember, those are equivalent values, so we can use whichever one we want. All right, next we have here that Olivia is a stockbroker. She makes 4% of her sales in commission. Last week she sold $7,200 worth of stocks. So how much did she make from commission? And then how much would she make in a year if she's making this much commission every single week? All right, so first we need to find out what is 4% of 7,200. Well, 4% is the same as going to 0.04. Now how do we do that? Well, if we have a 4 and we move the decimal place over 2 units, notice how we have a little space here? We need to fill in that space with a 0. So this would become 0.04. All right, now we multiply that by 7,200. So 7,200 times 0.04 would give us 288. 288. So how much did she make from commission? She made $288. All right, now, if she were to average that same commission every single week, how much would she make in commission in a year or after 52 weeks? Well, we would take our $288 that she made in 1 week and we would multiply it by 52. So 288 times 52 would give us a 14,976. So she would make $14,976 off commission a year based off making $288 in 1 week. All right, we've got another example for us here. The skin and seed of an avocado is about 30 to 40% of an avocado's weight. For an 8-ounce avocado, how many ounces of edible fruit does it have? All right, so an avocado would be 30 to 40%. So this is the same as 30 to 40% is the same as going from 0.3 to 0.4. All right, so let's first multiply our 0.3 times 8, and that is 0.3 times 8 equals 2.4. And then let's multiply our 0.4 times 8, which is equal to 0.4 times 8 would be equal to 3.2. So what is this telling us? That is saying that 2.4 to 3.2 ounces are skin and seed. So we need to subtract our 8 from this. So 8 minus 2.4 would be equal to 5.6, and 8 minus 3.2 would be equal to 4.8. So how many ounces of this are edible? Between 4.8 and 5.6 ounces are edible. All right. So that was it for us today. Today we worked with using rates to find percentages, and we also found percentages of numbers, like when we were working with finding 29% of 830 or something like that. And lastly, which is definitely the most important from this is basically going to be a tool that we all need to be able to do interchangeably now. We need to be able to convert between fractions, percents, and decimals whenever they come up. Alrighty, everybody, that's it for us today. I will see you all in class tomorrow. Have a fantastic rest of your day. Bye-bye, everyone.